Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss ripple and filters. Let's begin. What is ripple? As you know, in case of rectifier, that is the conversion of AC into DC, the output of rectifiers, that is a pulsating DC. Pulsating DC in the sense the output voltage is only if I plot the graph voltage and time, this is the output voltage, that is a pulsating DC. That pulsating DC at the rectifier output contains DC component as well as AC component. So, that AC component in the output of a rectifier is responsible for pulsation of that particular wave. Ripple is the AC component in the output of a rectifier. Ripple is that AC component which presents in the output of a rectifier. That is why it creates the pulsating DC. But if we get pure DC, then the graph is just like this, that is the pure DC. This is pulsating, that one is pulsating DC, this one is the pure DC form. As the output of rectifier, that is not the pure DC, that one is a pulsating DC, means the combination of AC and DC. So, that AC component is known as the ripple. Why ripple is important to study? By using ripple, we can easily calculate the effectiveness of a rectifier. The magnitude of ripple is very helpful to us in order to understand how the rectifier is effective or not. If the ripple is smaller, then the rectifier is more effective. Ripple is small in the sense we measure that ripple by introducing a term that is known as ripple factor. So, ripple factor is defined as the ratio between RMS value of AC component of the load current to the average value of the load current. Ripple factor gamma is equal to ISC divided by I of DC. This is equation number 1, whereas I of AC, that is the RMS value of AC component of load current, and I of DC, it is the average value of load current now. I RMS as I dc square plus I ac square, its under root, squaring on both sides, I rms square is equal to I dc square plus I ac square. From this, I of ac square is equal to I rms square minus I dc square, or simply I of AC is equal to I rms square minus I dc square under root. Now dividing I of dc on both sides, so I of AC divided by I of dc is equal to I rms square minus I dc square under root divided by I dc, that is ISC by IDC is the ripple factor. Gamma is equal to I rms square minus I dc square divided by I dc square under root. Or gamma is equal to I rms square divided by I dc square minus 1 under root, or gamma is equal to I rms divided by I dc whole square minus 1 under root. This is the expression for ripple factor. Now we can easily calculate the ripple factor for half wave rectifier and the ripple factor for full wave rectifier. For half wave rectifier, IRMS is equal to IM divided by 2, IM that is the peak current, and I of DC is equal to IM by pi. Therefore, ripple factor gamma is equal to IRMS square, that one is equal to IM square divided by 4 whole divided by IDC square, that is IM square divided by pi square minus 1, is under root, or gamma is equal to that one pi square divided by 4 minus 1 under root is equal to gamma, that value is 1.21. Here gamma 1.21 for a full wave rectifier. What that exact quantity indicates? For a half wave rectifier, the AC component is more than that of DC component in the output. Hence, more the pulsation or more the output situation. Therefore, the half wave rectifier is not effective for conversion of AC into DC. We write that important point. For a half wave rectifier, the AC component is more than the DC component. In the output, as a result, hence the pulsations are more in the output. Therefore, the half wave rectifier is not effective. For the conversion of AC into DC. AC into DC. Next, for full wave rectifier, what be the ripple factor? In case of full wave rectifier, I RMS is equal to Im divided by under root and I DC is equal to 2 Im divided by pi. Therefore, ripple factor gamma is equal to I RMS square. So, Im square divided by 2 whole divided by 4 Im square divided by pi square minus 1 under root, or gamma is equal to, that is pi square by 8 minus 1 under root, or gamma is equal to 0.48 for full wave rectifier. That be the ripple factor. Hence, we conclude that for a full wave rectifier, the AC component is less than the DC component in the output. Hence, the pulsations are less in the output. Consequently, we can say the full wave rectifier is effective for the conversion of AC into DC. AC into DC. Okay. Here half wave rectifier is not effective for the conversion of AC into DC, but in case of full wave rectifier, that is effective the conversion of AC into DC on the basis of ripple factor. That is ripple, then ripple factor, and mathematically we show the ripple factor for half wave rectifier and full wave rectifier. Then filters. As we saw, in case of ripple, means there are an AC component in the output of DC, as in case of rectifiers. To avoid that AC component, we use filters. So, a filter is a device that removes the AC component from the output of that of rectifier and allows only DC component to reach that of load. There are various types of filters. Most commonly we use the filters like capacitor filter, inductor filter, choke input filter and capacitor input filter. But here we have discussing about only two types of filter, that is capacitor filter and inductor filter. First one, capacitor filter. What is capacitor filter? The DC output voltage that is the voltage DC output voltage, that is the combination of AC plus DC, means it is a pulsating DC one to achieve only DC component. That is the rectifier output, rectifier output is a capacitor, then the load resistance RL. How capacitor helps us in order to filter? Capacitive reactance, capacitive reactance Xc is equal to 1 by omega c. Omega is the angular frequency, of current, which is equal to 2 pi nu. Nu is the frequency of current, nu and the frequency of current. Here omega is equal to 2 pi nu, 2 pi nu c. For DC frequency is 0, therefore Xc 1 by 0 means infinity. For AC, similarly for AC, mu have some finite value, mu does not 0, therefore Xc has some finite value. Xc infinity, what exactly it indicates? DC cannot pass through the capacitor. Because the capacitor offers infinite reactance to that direct current, but in case of AC, as the value of Xc is some finite, therefore AC can pass through the capacitor. Here DC cannot pass through that of capacitor, here AC can pass through that of capacitor. Therefore, as AC pass through that of capacitor, we draw the conclusion as AC can pass through the capacitor the pulsating direct voltage of rectifier output is applied across the capacitor now. We can show it by the graph. It with the load voltage, this is the rectifier output, that is the peak, but when we apply the capacitor filter that oppose the flow of DC, only allow the flow of AC. As a result, in the positive half cycle, when capacitor is charging in opposition, gradually it will be discharging, then charging, discharging, charging and discharging. At that of situation, the voltage across that of load just then suddenly decreases, then up, then decreases, then up, like this. That red one. So the output DC. Next, for inductor filter, with the pulsating DC, and time, that one is the input, where the circuit containing inductor, load resistance were connected in series. Here is the rectifier output, rectifier output. As we know, inductive reactance XL is equal to omega L, omega angular frequency of current, L that is the inductance or XL is equal to 2 pi nu L. Nu is the frequency. For AC, for DC, frequency 0, therefore XL is equal to 0. Again for AC, frequency does not equal to 0, therefore XL has some finite value not equal to 0. What exactly it indicates? In case of DC, the inductor allows DC to pass through it. Again in case of AC, the inductor opposes AC to pass through it. Allows DC to pass through it, allows AC to pass through it. Sorry, it opposes AC to pass through it. As a result, inductor act as a filter, means it allow DC, and finally at the output we obtain the voltage just like this. Some minor amount of pulsating DC, some minor component of AC also present. Okay. In this way, with the help of this video lecture, we understand the concept of ripple, ripple factor, ripple for half wave rectifier and full wave rectifier, filters, two filters, one is capacitor filter, another one is inductor filter. So, with this useful and informative notes, let me wind up this session. Thank you.